All right, we're going to start on the final part here of the review walkthrough. And we're going to start in on problem number 7. So I'll just continue on this sheet here. And problem 7 says find the real and imaginary zeros. Ooh. So find the real and imaginary zeros of each function. You may use a graphing calculator to check your answer, but show the algebraic steps to find the exact solutions. Okay, so we have here 7a starts with e to the 2x minus 3e to the x equals -2. This is a quadratic, so we're going to move everything to one side. So e to the 2x minus 3e to the x plus 2 equals 0. And you may want to use U substitution. U substitution is a method that you're really going to need if you plan to move on in higher math. So we're going to let u equal e to the x. And when I substitute u in, this right here becomes u squared minus 3u plus 2 equals 0. And then if I factor that, factors of 2 that add to 3 would be 2 and 1. Signs are the same. They're both negative. And then you get u equals 1 and u equals 2. And we need to substitute this back in because I don't care about the u. I care about e to the x. So we have e to the x equals 1 and e to the x equals 2. If we rewrite that as a logarithm, we have ln, because e is the base, ln of 1 equals x, and ln of 2 equals x. And we can estimate those in order to check our answer. So ln of 1 is 0, and ln of 2 is 0.693 for those answers. And if we plug those back in, you can just check on the calculator. So e to the 0 minus 3e to the 0, enter, and you get -2. So you can check, and then you can check the other one. You can actually put ln in there, so you can have e to the 2 ln of 2 if you want, minus 3e to the ln of 2. And maybe you can do that in your head there, that your e and your ln cancel, and you get -2. Okay, B is similar. So we have 3 to the 4x minus 3 to the 2x minus 6 equals 0. Okay, again, everything's already on one side, so we're going to use u substitution again. And this time we're going to say u is 3 to the 2x. Usually it's always this middle term, but you kind of have to be careful and make sure that they match up, that when you bring this middle term out of this, that it would be squared. So we have u squared minus minus u minus 6 equals 0. So factors of 6 that subtract to 1, that would be 3 and 2. Signs are different. The big one's negative, so minus 3 plus 2. So u equals 3, u equals -2. Plug this back in. So you have 3 to the 2x equals 3, and 3 to the 2x equals -2. So then we're going to use log base 3. So I have log base 3 of 3 equals 2x, and log base 3 of -2 equals 2x. Well, you cannot have a logarithm of a negative number, so this would produce no solution. Log base 3 of 3 is 1, equals 2x, so x equals a half. And again, when we plug that in to the original here, plug in a half. So 3 to the 4 times a half is 2, minus 3 to the 2 times a half is 1, minus 6, we get 0. Okay. And then when I would have plugged this one in, the log base 3, so second or alpha window gives you your log of any base. So 3, negative 2, you get no real solution there because of that negative. Okay, part C and D, we have x to the third minus 3x squared minus 13x plus 15 equals 0. Okay, we can look at P's and Q's. So P over Q, and P would be 15, Q is 1. So that's 1, 3, 5, 15, all over 1. So your possibilities are plus minus 1, plus minus 3, plus minus 5, and plus minus 15. Okay, so with this, we're going to do the synthetic division. And I like to just kind of speed this up. Here are my possible rational zeros. So I'm going to put this in the graphing calculator. X to the third minus 3x squared minus 13x plus 15. And if I look at the table, I'm going to go ahead and put these numbers in. You see I already have a 1 in there, so 1's a 0. So I'm going to do synthetic division with 1. So 1 minus 3 minus 13, 15. So that's 1, 1, negative 2, negative 2, negative 15, negative 15, 0. Negative 3 was already in there. That's a 0. So negative 3. So that's 1, negative 3, negative 5, 15, 0. And this gives me the last factor of x minus 5. So my factors are x minus 1, x plus 3, x minus 5. So my zeros are x equals 1, negative 3, and 5. And we can see here I was looking for 3 zeros, and I found all 3 of them. Okay, I'm going to go to a new page for D. Okay, so 7D says 2x to the third plus 5x squared minus 6x minus 9 equals 0. Again, we can list out our P's and Q's. So that's 9 over 2, which is 1, 3, 9 over 1, 2. So that's plus minus all of these over 1. So 1 plus minus 3 plus minus 9 plus minus all those over 2. So a half, 3 halves, 9 halves. Again, to speed this up, we can look at the table. So 2x to the third plus 5x squared minus 6x minus 9. And we'll plug these numbers in. So look at the table. Plug these numbers in. So I have 1 minus 1. Oh, minus 1 gave me a 0. So I'm going to synthetically divide with that. So 2, 5, negative 6, negative 9. So that's 2, negative 2, 3, negative 3, negative 9, 9, 0. Okay, so 3, negative 3. Okay, negative 3 gave me a 0 there. So I'm going to divide by negative 3. So that's 2. That's minus 6, minus 3, 9, and 0. And this gives me the last one here. So my factors here are x plus 1, x plus 3, and 2x minus 3. So my zeros are negative 1, negative 3, and 3 halves. Okay, so make sure we see those P's and Q's and the synthetic division there. Okay, number 8, we kind of start the word problems here. So number 8 is a word problem over Newton's law of cooling. So it gives you this formula here where T of S is the surrounding temperature and D naught is the initial temperature minus the surrounding temperature. Okay, and it gives us two scenarios here. So it says a car engine runs at a temperature of 100 degrees Fahrenheit. When the engine is turned off, it cools according to Newton's law of cooling, where with a constant of K equal 0.0341, where the time is measured in minutes. Find the time needed for the engine to cool to 90 degrees Fahrenheit if the surrounding temperature is 60 degrees Fahrenheit. Okay, so we have this formula. T of T equals T sub S plus D naught E to the minus KT. Okay, and if we read this word problem here, it says that we're looking for the time. So that will be left alone. It gives us K. So we're going to say E to the minus, it says 0.0341, and we don't know what T is. D naught, it says, is the difference. Where to say that? The difference in the initial temperature minus the surrounding temperature. So D naught would be your initial temperature, which is 190, minus the surrounding temperature, which is 60. Okay, so that equals D naught. D naught would be 130 then. So 130 times that plus TS is the surrounding temperature, so that would be 60 equals your ending temperature or your temperature after the given time, and we want the engine to cool to 90. Okay, so here's your equation, and we're just going to solve it. Notice I have an E, so we're going to be looking at using the ln. So we're going to minus 60. So 30 equals 130 E to the minus 0.0341 T. Divide both sides by 130. So you get 30 over 130, which you can reduce, equals E to the negative 0.0341 T. We're going to take the ln of both sides to get rid of that E. So I have ln, and if I reduce those zeros, I get 3 over 13 equals the E and the ln cancel, and I'm just left with this, minus 0.0341 T. And then we'll divide both sides by negative 0.0341. So T equals ln of 3 over 13 divided by negative 0.0341, which is about, if I put this in on the calculator, we have ln of 3 over 13 divided by negative 0.0341. So that rounds to 43 there. So we have 43, and I believe it said time was in minutes. Let's see. I don't see where it does say that, but we're going to say it's in minutes, I believe. Okay, so that was A. B, okay, we're still using Newton's cooling law here, surrounding temperature. Okay, so it says a roasted turkey is taken away from an oven when its temperature has reached 185 degrees Fahrenheit and is placed on the table in a room where the temperature is 75 degrees Fahrenheit. If the temperature of the turkey is 150 after half an hour, what is the temperature after 45 minutes? How many hours will the turkey take to cool to 100 degrees? Okay, so there's a couple questions in here. And the first question is, if the temperature of the turkey is 150 after half an hour, what's the temperature after 45? And if you notice in here, they don't give us K. Okay, so we first have to find K in this problem. So we have T of T equals T sub S plus D naught e to the minus K T. And we're going to leave T in minutes for all this. You notice that they have some hours down there, but we're going to make sure everything is in minutes. Okay, so T after temperature after time. Well, it says if the turkey is 150 degrees after half an hour. Okay, so we're going to say this was 150, and T would be 30 minutes. I don't know what K is. E. D naught would be the initial temperature minus the surrounding temperature. Well, the initial temperature was 185 minus the surrounding temperature, which is 85. So that would be 110 plus the surrounding temperature, which was 75. So we have that equation there, and we need to solve this for K. So we're going to subtract 75. Okay, so 150 minus 75, 75 plus, equals 110 e to the minus k 30. So divide both sides by 110. You get 15 over 22 equals e to the minus k 30. Take the ln of both sides to get rid of that e. So 15 over 22 equals minus 30k. I just switched those. Divide by negative 30, and you get k equals, so ln of 15 over 22 divided by negative 30. You see how I wrote that in the calculator there? So you get k to be 0.0128. The more decimals you have is good. And if you want to turn this into a fraction, it doesn't turn into a fraction. Okay. Okay, so this is K. And it says, what temperature is it after 45 minutes? So now we're going to use all the same stuff, except we don't know T of T. So I really want T of 45 and see what that equals. So TS is still the same. D naught is still the same. E to the minus 0.0128 T. T was 45. Okay, so we can put all this into the calculator here. So we got 75 plus 110 e to the minus 0.0128 times 45. And that is 136.84 degrees Fahrenheit. Okay, so it dropped a little bit more. After 30 minutes, it was 150. After 45 minutes, it's 136. Now, because we used minutes to find K, we're going to use minutes all the way through. If I used hours to find K, then I'd have to use hours all the way through. Okay, and then the last question says, after how many hours will the turkey cool to 100 degrees? Okay, so we're gonna we want it to be at 100 degrees, and that's 75 plus 110 e to the negative 0.0128 t. So we want, it's going from 100, what was that, 185 down to 100 degrees. How long will it take? And it says how many hours. So we're going to get minutes, so then we need to translate that to hours. So we're going to subtract 75. So it's 25 equals 110 e to the minus 0.0128 t. Divide both sides by 110. So 25 divided by 110 is 5 over 22 equals e to the minus 0.0128 t. Take the ln of both sides. So 5 over 22 negative 0.0128 t, and divide by your constant there. So negative 0.0128. And t equals, so ln of 5 over 22 divided by negative 0.0128. So 115.75 minutes. Okay, so 60 minutes in an hour, so we're going to divide that by 60. So that would be almost 2 hours. That is 1 hour and 0.93 of another hour. So if I subtract 1 and multiply it by 60, I get 56 minutes. 1 hour, 56 minutes. Okay, maybe your teacher is okay with you putting 1.93 hours or 115.75 minutes. Kind of all depends. Okay, question 9. Question 9 is radioactive decay. So you begin with 50 grams of radioactive substance. After 11 days, the sample has decayed to 14 grams. Write an exponential function that gives the amount of substance p of x after x days to the nearest day. What is the half-life of the substance? Okay, so half-life formula. There's actually 2 of them that you can use. And one of them looks like P naught 1/2 T over D. And D is the amount of, it's the half-life time. Okay. P naught is your initial population. This probably should be P of T, your population after a given time. So here it says after 11 days, the sample has decayed to 14. You started with 50. So our ending population would be 14 grams. We started with 50 grams. We have a half-life, and our time was 11 days, and we don't know D. Okay, the other formula that you could use is very similar. It looks like this. M equals M naught 2 to the negative T over D. Negative T over H, and they say H equals ln 2 over H. H is or R, this is R. Okay, so this formula is just the same. They just made this exponent negative, which takes the half out of there. This is the one that I believe is easiest to use, but they are the same. Okay, H is still your half-life time. This is still half-life time. This is your time, how long you're taking. You won't really need that. Okay, so solving this, we're going to divide by 50. So 14 over 50 would be 7 over 25 equals 1/2 11 over D. We're going to take the log base 1/2 of both sides. So that's log base 1/2 of 7 over 25 equals 11 over D. Okay, if I multiply both sides by D, so D log of 1/2, 7 over 25 equals 11. And now I divide by this log a half, 7 over 25 on both sides. So D equals 11 over log base a half, 7 over 25, which is about 11 divided by log base a half, 7 over 25. Whoops. That's what we got. 5.99 days. And that's the half-life time. So it takes almost 6 days to divide this thing in half. Okay, and it's in days because our 11 was in days. If 11 was in minutes, everything would be in minutes. If it was in hours, everything would be in hours. Okay, to the nearest day, what is the half-life? I guess so we'd round that to 6 days because it says round to the nearest day. To the nearest day, right here, to the nearest day. Okay, part B says you begin with 400 grams of radioactive substance. After 38 days, the sample has decayed to 14 grams. Write an exponential function that gives the amount of substance after X days. To the nearest day, what is the half-life? Okay, again, we're going to use P of T equals P naught 1/2 T over D. So it says that you begin with 400 grams, 1/2. After 38 days, you get 14 grams. Okay. So again, just divide by 400. So 14 over 400 reduces to 7 over 200 equals a half, 38 over D. So we have log base a half. The both sides, that cancels. And then you're going to multiply by D. So you get D log of a half, 7 over 200 equals 38. And then divide by this log half, 7 over 200. So you have 38 divided by log base half of 7 over 200. So D equals 7.8569. So 8 days. So in 8 days, your population will be cut in half. Okay. All right, so that was number 9. Number 10, I'll just get a new page here. Okay, number 10, exponential and linear functions. A species of frogs is introduced to a pond with initial population of 12. After 5 years, the estimated population is 340 frogs. Write a linear function to model the population after 2 years and write an exponential function. Okay, so we have some ordered pairs here. So 10a, so we can kind of look at our xy here. And initially, so x would actually be time, and this would be population after time, still x's and y's. So at initial time 0, we have 12 frogs. And after 5 years, so times in years, we have 634 frogs. Okay, it says write a linear. Okay, linear is y equals mx plus b. I already have my y-intercept, which is what b is, so that's 12 plus x. This is our slope. Okay, so that's rise over run. So slope equals change of y over change of x. So if you subtract your y's, so that's 634 minus 12 over subtract your x's, 5 minus 0. You will get your slope. So that's 634 minus 12. 622 over 5, which I don't think reduces. Nope. So there's our slope. I didn't leave enough room. So 622 over 5 equals y. And to get it in the right form, we'd say P of P of t is what it wants. 622 over 5 times t plus 12. This is a linear model for those data points. For an exponential model, we're going to use the function p equals p naught e to the rt. Okay, so we have some points right here. We want to use the one that's not 0 if we can. So our initial population was 12, so t, so that is 12. E, when I plug in P of t and t, that's when I'm going to use the second one. So this is going to equal 634. R we don't know, and then t would be 5 years. Okay, we'll solve this for R. So divide both sides by 12. And 634 divided by 12, math fraction, would be 317 over 6 equals e to the r times 5. Take the ln of both sides. So you have ln of 317 over 6 equals 5r, and then divide by 5. So r is about, so you have ln of 317 over 6 divided by 5. No fraction. So we'll go to 4 decimals, so 0.7934. So then I have P of t equals P naught, which was 12 e to the 0.7934 times t. This would be your exponential population model, which is a better model. This is an absolute better model than a linear function for it. Okay, part B says a species of snakes is introduced to an island with an initial population of 2. After 15 years, you estimate the population is 1450. Write a linear function and exponential. Okay, so at time and population of our time, so you start with 2 snakes, so 0, 2. And then after 15 years, you have 1450. Okay, and we're going to go through the exact same process we did with these, with the frogs, as we do with the snakes. So linear, we have P of t equals mt plus b. So our initial population here is 2 plus t. We need to find slope. So that's change of y over change of x. So your change of y would be 1450 minus 2. Change of x would be 15 minus 0. So that's 1450 minus 2 divided by 15, which doesn't reduce any. So it's 1448 over 15. So 1448 over 15, t equals P of t. Okay, so our exponential is going to be P of t equals P naught E R of t. So our initial population was 2, E, we don't know R, and after 15 years, we have 1450. The first thing we're going to do is divide both sides by 2. When you do that, you get 725 equals E to the 15 R. Take the ln of both sides, that cancels your E. So ln of 725 equals 15R. And divide both sides by 15. R is about, so ln of 725 over 15.4391. So your function or your model here is 2e to the 0.4391 times t for your exponential growth of population, those snakes. Okay, and lastly, question 11 is about money. There are kind of two cases here. So the bank is offering two different savings accounts, and we need to choose the best one. So option 1, investments are compounded continuously at a rate of 4.15 interest per year. Investments are compounded annually at a rate of 4.65. Which option would you choose? Justify your answer by finding the difference in earning potential. Okay, so with compounded continuously, we got two problems here, so we'll split this up. So compounded continuously is our PERT equation. So P e to the RT, the amount equals your principal. And then when you compound like monthly or daily or annually or anything like that, that's A equals P to the 1 plus R over N to the NT, where N is the number of compounds per year. Okay, so for option 1, we're going to compound continuously, so that's this one. So A equals PE to the RT. We know what the rate is, so A equals PE to the 0.0415 T. For that. So I can look at this rate, this growth right here, which if I put that into the calculator, we have E to the 0.0415. So that becomes 1.0424 T for that. So option 2, and that's what we're going to compare, that number right there. Option 2 is compounded annually, so that's once a year. So we have A equals P to the 1 plus my rate is 0.0465 over 1, 1 to the T. Okay, so when I calculate this, it's to the first power, so I don't have to do anything with that. So 1 plus 0.0465, which is over 1, so you don't have to divide. So this is 1.0465 to the T. Now, the one that you want has the higher number. Okay, so this one has the higher number, so this is best. Okay, because the growth rate, the difference in earning potential is better here. Okay, this number's higher than that number. Okay, for part B, we have investments are compounded monthly at 5.6. The investments are compounded daily at 5.4, and we're doing the same thing. Okay, so same equations over here, same equation. So option 1 is compounded monthly. So that's A equals P, 1 plus the rate is 0.056 monthly, so that's 12T. So that's A equals P to the 1 plus 0.056 over 12. And we're going to raise that to the 12th. So you get 1.0575 T. And then option 2 is compounded daily. So A equals P 1 plus 0.054 over 365. 365 to the T. So this would be 1 plus 0.054 over 365. And we're going to raise that to the 365. So A equals P 1.0555 to the T. And we're going to compare these two numbers. It looks like this one is higher. So option 1 would be your best. And if you don't kind of remember how to do that, you could plug numbers in. Like say you start at 1,000 over 5 years. Okay, plug it in and see which one turns out the best. Okay, but this is comparing the earning potentials. All right, so that's the whole review. If you have questions, feel free to reach out.